Hello everyone and welcome back to my channel. In this video, we are going to dive deep into a very interesting binary decoding problem. The question asks us whether the last bit in the array must represent a 1 bit and 2 bit character. Okay, so we will go through the entire solution line by line and understand the logic behind each step, and finally decode exactly how the pointer moves. So sit back, relax, and let's begin breaking this problem beautifully and deeply. So basically in line 1 we start creating a class named solution. Most coding platform like Leetcode expect solution inside a class so the driver code can automatically call the class method. This line doesn't do any computation. It is simply the structural setup. Okay. Now comes to line second, that is diff is 1 bit character set comma bits. Here we define the actual function that will solve the problem. The function name is 1 bit character, okay, which is fixed because the platform expects this exact name. The function takes one argument, bits, which is a list of binary value, zeros and 1. The purpose of this method is to process the array according to encoding rules and decide if the last bit form a single bit character. Now comes to line 3, that is I is equal to 0. We initialize a pointer I to 0. This pointer will represent the current position of our decoder in its bit array. Okay, you can imagine I as a reader that can scan the bit stream left to right. Every time it sees a 0, it's moved forward by one step because it's a 1 bit character. In A1, it moved forward by 2 steps because it's a 2 bit character. So this pointer movement is the heart of this solution. Now comes to line 4, that is n is equal to len bits. Here we store the length of the bits array in the n so that we don't repeatedly call len bits inside the loop. This makes the code slightly more efficient and cleaner. Now comes to line 6. While I is less than n minus 1, here this line starts a loop that continues until the pointer reaches the second last index. Why second last? Why second last? Because the problem statement guarantees that the array ends with a 0. We want to know whether this final 0 is a standalone 1 bit character or part of a 2 bit character. Okay, so we only simulate decoding until we are just before the last bit. If during decoding the pointer lands exactly on the last bit, that's a 1 bit character. If it's jump over it, then the last bit character must be used as a part of 2 bit character. Now come to line number 6 to 9, where we have just make a condition. In this, if bits I is double equal to 1, I plus is equal to 2, else I plus is equal to 1. Here we have a deep explanation, which means the character in this problem can be of two types. It's a 1 bit character or 2 bit character. In 1 bit character, which is represented by 0, which is always a single bit. Whenever the pointer sees a 0, it means this bit is a complete character. Okay, and in third, so we simply move the pointer by one step. Now comes to the 2 bit character, which is represented by 10 or 11. Okay, which is given in the questions. Okay, the second character can be represented by 2 bits character 10 and 11, and the first character can be represented by 1 bit 0. Okay, so come to line 2 bit character. So in first point, like we have to notice that always start with a A1. Okay, this means that whenever we encounter a 1, it must combine with the next bit to form a 2 bit character. Okay, so we move the pointer by 2 steps. So question is, why this logic always work? Because the encoding rules ensure that a 1 can never be a standalone character. Also, a 0 can always be a standalone character. There are no ambiguous cases, so each time bits I is equal to 1. Okay, here, wait. Just wait, yes. So I is double equal to 1. Yes, I is skipped 2 bits. Here, I plus is equal to 2. And if I is equal to 0, okay, so skip 1 bit, else, yeah? Okay, so we keep doing until we reach the end of the array. So in line number 12, we return I is equal to n minus 1. This is the moment of the truth. After we finishing scan the array, if the pointer I land exactly on the last index n minus 1, then the last bit was decoded as a 1 bit character, so we return true. If the pointer overshoots last index, it means the last bit was consumed a part of 2 bit character. Sorry, so we return false. This comparison I is double equal to n minus 1 is a final check that tells us whether the last bit stands alone. So, and the complete deep breakdown of the solution, we used a pointer based approach to simulate exactly how the decoding happens. By carefully jumping either one step or two steps, depending on the bit value, we can determine with certainty whether the final bit is a 1 bit character. This method is efficient, elegant, and perfectly aligned with how the encoding rules work. So, thank you for watching this detailed explanation. Keep coding, keep learning, and I will see you in the next problem. Okay? So, have a good day. Please like, subscribe, share, and comment on this question. Okay? And please try to subscribe my channel too. Okay? Have a good day. Once again.